Self-learning AI, also known as artificial intelligence that can improve and adapt without explicit programming, holds immense potential for the future of scientific discoveries. Here's how self-learning AI is set to revolutionize the scientific landscape. 1. Accelerated research and discovery. Self-learning. AI can process vast amounts of data at speeds and scales far beyond human capability. This enables researchers to quickly identify patterns, correlations, and anomalies, accelerating the pace of scientific discovery. For example, AI can analyze genomic data to uncover new insights into genetic diseases, leading to breakthroughs in personalized medicine. 2. Autonomous experimentation. AI-powered systems can design and conduct experiments autonomously, optimizing parameters and learning from results to improve future experiments. This approach, known as robot scientists, can streamline the research process, reduce human error, and allow scientists to focus on higher-level problem-solving and hypothesis generation. 3. Drug discovery and development. Self-learning. AI can significantly speed up the drug discovery process by predicting the efficacy and safety of potential drug candidates. AI algorithms can analyze chemical compounds, simulate their interactions with biological targets, and identify promising candidates for further testing. This can reduce the time and cost associated with bringing new drugs to market. 4. Climate and environmental science. AI can analyze complex environmental data to model climate change, predict natural disasters, and develop strategies for sustainable resource management. Self-learning AI can continuously update its models based on new data, improving the accuracy of predictions and helping policymakers make informed decisions. 5. Advanced materials science. AI can assist in the discovery of new materials with unique properties for applications in energy, electronics, and manufacturing. By analyzing data from experiments and simulations, self-learning AI can identify novel materials and optimize their properties for specific uses. 6. Space exploration. AI-driven systems can analyze vast amounts of data from space missions, identifying celestial phenomena and guiding exploration efforts. Self-learning. AI can help navigate spacecraft, analyze samples, and autonomously conduct experiments, expanding our understanding of the universe. 7. Interdisciplinary research. AI can bridge the gap between different scientific disciplines, facilitating interdisciplinary research and collaboration. By integrating data and knowledge from various fields, self-learning AI can generate new hypotheses and innovative solutions to complex problems. 8. Ethical and responsible research. While AI holds great promise, it is essential to ensure that its use in scientific research is ethical and responsible. Researchers must address potential biases in AI algorithms, ensure transparency in AI-driven research, and establish guidelines for the ethical use of AI in science. In conclusion, self-learning AI has the potential to transform the scientific landscape by accelerating research, enabling autonomous experimentation, and facilitating interdisciplinary collaboration. As AI continues to advance, it will play an increasingly critical role in driving scientific discoveries and solving some of the world's most pressing challenges. What are your thoughts on the role of self-learning AI in scientific research? Do you see it as a game changer in the field,